Hello, everyone. I'm Miles, the company's CFO and a private equity investor. People use annuity thinking every day. They just don't call it annuity anymore, because an annuity isn't just a formula, it's the mathematical language of time compressed. A lot of things like project valuation, debt, leasing, and mergers and acquisitions are essentially doing the same thing, taking a series of future promises, treating them as a geometric series, and adding them up to figure out what they're worth today. Annuities come from the simplest of things. If starting next year you receive C every year forever, how much is that worth today? The present value of this kind of fixed perpetual annuity equals C plus C divided by 1 plus R plus C divided by 1 plus R squared, and so on, adding up to infinity. Basic knowledge of geometric series from high school tells us that the present value equals C divided by R when the cash flow starts at C and grows at a fixed rate every year, continuing forever. The present value of this kind of growing perpetuity equals C divided by R minus G. If starting next year you receive C every year for T years, how much is that worth today? The present value of this type of fixed-term annuity equals C times 1 over R minus 1 over R times 1 plus R to the power of T. If starting next year the amount starts at C and grows by G each year, how much is that worth today? The present value of this type of growing term annuity equals C times 1 over R minus G minus 1 plus G to the power of T divided by R minus G times 1 plus R to the power of T. If you understand geometric series, these formulas are very easy to derive. The key is to make sure the timeline and the corresponding amounts match up correctly. Next, let's survive to learn. ABC Company has established the Green Horizon Fund to support its annual carbon offset program and has decided to make a one-time investment today. The discount rate, or WACC, is set at 8%. Perpetuity, for $250,000 paid annually forever, the initial investment is $250,000 divided by 0.08, totaling $3,125,000. This is the price tag for a permanent commitment. For a growing perpetuity starting at $250,000, growing 3% annually, how much is needed today? PV equals 250,000 over 0.08 minus 0.03, totaling 5 million. 3% growth adds 1.875 million in value. Part 2. Finite annuity. The board says to do it for only 15 years. What is the present value, PV, of this commitment? The present value of a fixed 15-year annuity equals 250,000 times 1 divided by 0.08 minus 1 divided by 0.08 multiplied by 1 plus 0.08 to the 15th power, which is about 2.14 million. If it's a growing 15-year annuity with costs increasing by 3% each year, how much funding needs to be set aside today? The present value is about 2.54 million. Once the term is cut, more than half of the value instantly evaporates. Part 3. Loans disguised as annuities. ABC Company decides to borrow 3.125 million today to pay for a fixed perpetual annuity. The 10-year loan has an APR of 6% with 120 monthly payments, so the effective annual interest rate, APY, is 6.1678%, and the monthly interest rate is 0.5%. Using the fixed-term annuity formula, the monthly payment C is $34,693. If ABC Company decides to pay off the loan early with a lump sum after the 60th payment, that is after 5 years, then the repayment amount will be for the remaining 60 payments. The present value at the end of the 60th month, calculated using the fixed-term annuity formula, PV at 60 equals 1,794,562. In the end, corporate finance isn't about calculating how much money you'll make in the future, but about determining which long-term commitments are worth paying for right now. And annuities help you understand how time creates the order of capital.